Good morning to one and all. So is the screen visible?
Yes, sir.
Yes, sir.
Okay. So in the morning you have the Josh then. This is the first time some two persons they have replied for my question. Okay, very good. Still some people are joining. Just a minute. Number 19. So in the previous class, we have started already discussion. We have discussed about the IEC standards, that is International Electrotechnical Commission standards. Totally based on that, these standards are broken into 6 parts. We have told that one. The first one is general, related to the general standards, environment. The next one is limits, and the fourth one is testing and measurement. Fifth one is, what is that one? Fifth one, installation, and sixth one is miscellaneous. Okay, so these 6 parts we have discussed in the previous class, but apart from those 6 parts, number 24, 3. Okay, apart from 6, those general instructions or general standards are there. Those we are going to discuss in the today class here. Roll number 14. Okay, so the general, what we are going to tell that one, that is the what are the limitations are there, it is going to give that general standards over there. Just a minute again. Who is this Siddhi Sinde? I don't know. Yesterday also she is joining. Anybody? Do you know Siddhi Sinde? They are trying to join to the class, but I am not admitting because is there any your classmate is there? Siddhi Sinde बोल के है ये कोई classmate? No, madam. Anybody is there?
No, sir.
सिद्धि सिंधे बोल के है क्या कोई क्लासमेट आपका? कोई तो रिप्लाई करो.
नहीं, sir.
नहीं ना? Then no need to accept that. So the general standards, what it is going to do, these type of standards, it is going to deal with. Okay, क्यों कितना बार ज्वाइन होते हैं लोग? 23. So lock the meeting then. It is going to deal with introduction, fundamental principles, what are the definitions, terminologies, and this part 1, it is going to describe the application interpretations, actually fundamental definitions and terms it is going to give. So the second one related to the compatibility, we are going to call that one classifications of environment, what is the equipment environment, where we have to place and all the things that is based on that. This second standards it is going to give, that is going to give the or define the characteristics of environment. The third one, it is going to give the limits, that is called emission and immunity limits, it is going to define that one. And fourth one, that is required for the testing and measurements here now. So while doing the testing, what are the, it is going to give you the procedure for the testing, how we have to test the equipments. Next, it is going to give the for the parts and all the things measurement, it is going to give the standards, it is going to give, and it is going to give the guidelines for the measurement, and it is going to give for the procedure for the testing here now. And fourth one is installation is there. It is also going to provide the instructions or guidelines for the application orientation, how to install and what are the problems will arise during the installation. These are all the things it is going to give that one. These standards, it is going to provide guidelines in application of equipment such as earthing, cabling, why you have to do the earthing, the body, any leakage is there, it will go to the earthing, like that. We are going to consider the fifth one. Up to here we have discussed this last one. The hurry we have finished, I think. Okay. So that is miscellaneous here. Now these miscellaneous standards are generic standards. We are going to call that one. Again, it is whatever the limits we have divided immunity and emissions. This one also we have discussed already. Okay. So equipment in general categories, what are the types are there? So those it is going to give miscellaneous other than this testing, measurement, and installation, limits. Other than that, others guidelines and definitions it is going to provide. That is those type of standards we are going to call as miscellaneous standard. That is part 6. Okay. So the IEC standards relating to harmonics here now. Relating to harmonics generally fall in part 2 and 3. Part 2 is what? That is the environment. Part 3 is nothing but limits here now. So the voltage sag, voltage swell, under voltage, over voltage, these all are the limits only, no? Yes or no? They have particular limits of voltages, currents, and all the things. So for that reason, these IEC standards are there. These are relating to harmonics, especially relating to the harmonics. They are generally fall in part 2, that is called environment, and part 3, that is called limits here. Unlike the IEEE standards on a harmonics, where there is only a single publication covering all the issues related to the harmonics here. We have IEEE standards also, but there is only one paper or publication that which covers all the issues it is going to cover in one place only. It is like this IEC, it is not 6 different parts. Only one part is there, one single publication. They are going to take all the issues and they are going to give the provide the standards over there, covering all issues related to the harmonics. But IEC standards on harmonics are separated into several publications here. Now, this IEC is that it is separated based on the issues. It has separated into several publications. It has done over there. Okay. There are standards dealing with the environments and limits which are further broken down based on the voltage and current levels here. These standards, IEC standards are there. Again, they are further broke down into, that is the based on the voltage level, current level. Again, we have broken that IEC standards over there. We have broken into 6 parts based on the different issues. Again, these 6 parts, in this one, 6.1, second one we consider that is limit. 2 we have considered 2.2, that is cut nothing but that is second E. Here again 1 2 3 4 5 1 2 3 4 5 parts are there here. Now we have broken into based on the voltage and current levels. We have broken here. Now some examples they have given here. Now IEC 6100-2-2 here. So this one, it is nothing but part 2. 6100 is IEC standard, and this 2 indicates part 2. In that part 2, sub part is that is called 2 here. That is in 1993 they have invented this one, electromagnetic compatibility, that is called EMC. We are going to call electromagnetic compatibility. That is this 6100 IEC, that is called electromagnetic compatibility. We are going to call that one. That is part 2. This 2 indicates part 2. That is called environment. Next, the section 2 here. Now that section 2, that is called compatibility levels for low frequency conductor disturbances and signaling in public low voltage power supply. This signal 2, it is going to indicate that it is to the compatibility level for low frequency conducted disturbances and signaling in public low level, that is power supply system here. So like this, they have separated here. Now this one IEC 6100 is electromagnetic compatibility. This is part 2. This is section 2, which is related to this low frequency low voltage power supply system here. So like that, the harmonics next we will consider again IEC 6100. Just a minute. 6100. That is EMC we are going to call. This 3 is the part 3, that is called limits. It is going to consider, and this is section 2 here. Now section 2 in the year of 2000 they have this one published this standard here now. So that is IEC 61,000, that is called electromagnetic compatibility. EMC part 3, that is limits. Section 2, that it limits for harmonic current emission here. This one, the second section, it is going to limit the harmonic current emissions, it is going to limit over there. So equipment input current up to and including 16 ampere per phase they have told here. In that paper they have published here. Similarly, IEC 61,000-3-4 here now, part 3 and section 4 here now. Section 2 we have discussed. In the section 4, we are going to give different standards that is implemented in 1998 here now. Section 4, that is called limitation of emission of harmonic currents in low voltage power supply for equipment with rated current greater than 16 ampere. So the rated current greater than 16 ampere, if the low voltage is there, emission for the harmonic currents in low voltage power supply, this is going to indicate, that is section 4 here. Next, section 6 is there again here. This is IEC 61,000 is EMC. This is part 3, that is called limit. The section 6 is nothing but assessment of emission limits for distorting load in megavolt and high voltage power system here. Here we have considered low voltage. Here we have considered high voltage. That is EMC basic publications. We are going to call this one here. Now 1996 volt they have published this one. Just to understanding this harmonics, they are going to fall in part 2 and part 3. See here, this is part 2, that is environment. This is part 3, part 3, part 3. It is going to fall in part 3 only here. Part 3 only, it is going to follow. So it completes the standards of the IEC standards actually. It completes the IEC standards, and this is the international standards, that is called IEEE standards we have. So the only one topic left to finish the chapter, that is called CBEMA curve and ITI curve, we are going to call that. CBEMA curve here. Now, CBEMA is nothing but Computer Business Equipment Manufacturing Association. Computer Business Equipment Manufacturer Association. And ITI is nothing but Information Technology Industry here. ITI, Information Technology Industry, and CBEMA, Computer Business Equipment Manufacturing Association. See, this is CBEMA is the part of ITI actually here. It will comes under ITI only, but starting it has developed the one curve here. No, which one it is going to give the explanation and what are the tolerances are there, what are the envelope, the acceptation range percentage, it is going to give the curve here. They have published one paper on that one, that is CBEMA and ITI curve, we are going to call that one. Okay, so CBEMA is Computer Business Equipment Manufacturers Associations here, no, CBEMA. So first, actually, the CBEMA, it will comes under ITI only, Information Technology Industry Council only. So we'll discuss this one. A set of curves published by the ITI here. This curve is also published by ITI only. So the set of curves published by the Information Technology Industry Council, that is called IITI, representing the withstanding capability of the computers connected to 120 volt power supply here now, 120 volt power systems in terms of magnitude and duration of the voltage disturbance. So for 120 volt power system, it is going to give the magnitude, duration of the voltage disturbance, at duration how much voltage is disturbed, at duration is what, per 1 second, 30 cycles, like that it is going to give here. The ITI curve replaces the curves originally developed by the ITI's predecessor organization here now. One of the ITI's predecessor organization, that is called Computer Business Equipment Manufacturing Association, that is called CBEMA here now. This curve already first one is implemented by CBEMA only. The curve is implemented by CBEMA only, but this curve is replaced by this ITI curve. One more they have developed, that is called ITI curve here now. Okay, so that one only they have written. The ITI curve replaces the curves originally developed by ITI predecessor organization. It is one part of the ITI organization, the Computer Business Manufacturing Association, CBMA curve here. So one of the most frequently employed display of data to represent the power quality is so-called CBMA curve here. That is, this is the most frequently employed display of data to represent the power system quality or power quality here. So they are going to display the data voltage, at what duration the voltage will fall, how much percentage is there. So that is called frequently employed. This is the first one we are going to call most frequently that is used, that is called CBMA curve they have developed here. A portion of the curve adopted from IEEE standards for 4469 here. This one portion of the curve is developed by IEEE standard. Just a minute.
Sir, your voice is not audible.
Sorry, I have unmuted. Unmute nahi kiya tha. Okay, so this a portion of this MBEMA curve, CBEMA curve, what we are going to take, we are adopting from the IEEE standard that is called 4469. We are adopted here. We have adopted from 4469. That I will show the curve here now. This is the curve we are going to call CBEMA curve. I erase all the things. See here, this one, it has the x-axis indicate the time cycle, that is the, it will start from 0.12 onwards over there, and y-axis it is going to start the percentage of voltage, it is going to start here, percentage of voltage. So for the this one we are going to consider 100 to 110, 82, the sorry, this one 92, this is 110, 20 or 110 here now, or 100 exactly. We are going to consider this one as tolerance envelope. We are going to consider that 100 is considered as tolerance envelope here. So if it is less than this tolerance, that one it is going to indicate that it is under voltage or suddenly switching the loads and all the things here. So voltage drop we are going to consider here. Voltage drop or under voltage system we are going to consider. So the above the tolerance envelope, what we are going to consider here, over voltages are switching the capacitor banks and all the things we are going to consider here. Suddenly removing the load and all the things here. This is over voltage here. Same thing they have explained. This is computer generated wave here, no curve here, no. So they have started from 0.1 here, but actually the over voltage is above the envelope, it is going to start from 0.001 here. Around 375% it is there actually. 0.001. That is here 150% it is showing here, but it is nearly 375% of that over voltage is there. That much they have shown over there here now. Okay, it is not because of the limits of power system, they are not showing here. From 0.1 onwards they have considered that one. So I think somewhere they have mentioned in the explanation also here. So this curve was originally, whatever this curve I have shown here now, this one, it is originally developed by a computer business equipment manufacturing association here now, one of the predecessor organization of the ITI. That one developed this first curve. It is developed by CBEMA to describe the tolerance of mainframe computer equipment to the magnitude and duration of the voltage variation of the power system here. This CBEMA curve is developed and it is going to describe the tolerance of the magnitude and duration of the voltage variation of the power system here. So that is computer equipments by using that one that is going to develop and it is going to give the clear picture of that one. While many other modern computers have greater tolerance than this, we have considered 120 volt as a tolerance here, but many other 100 we have considered here. Many other organizations are there, computers have there, they have considered greater tolerance than this, but the curve has become a standard design here now. The curve has become standard design target for sensitive equipment to be applied on the power system and common format for reporting power quality variation data here. This one they have considered standard design target and it is sensitive for the equipment and to be applied on the power system and it is common format for reporting power quality variation data here. So for that reason, this is the curve that is developed by CBEMA. So the curve name we are going to call as CBEMA curve here. CBEMA curve we are going to call that one. So this is the curve. Already have explained that one. This is above the tolerance envelope and this is below the tolerance envelope. This one it is indicates that voltage drop, it is over voltages or voltage rise, it is going to indicate here now. So we are going to consider the tolerance level at 100 volts we can consider here, or 120 volts we can tell that. The axis represents the magnitude and direction of the duration of the event here now. The y-axis it is indicate the magnitude and x-axis it is going to indicate the duration of that one. The points below the envelope here now, whatever the points below the envelope or tolerance envelope is there, are presumed to cause the load to drop out due to lack of energy here. It is going to presume to drop out the load to drop out due to what it indicates, lack of energy. There is no sufficient energy, that one. So these are presumed to cause load here, no, to cause the load to drop out due to lack of energy. But the points above the envelope are presumed to cause other malfunctions such as insulation failure ho sakte, over voltage strip and over excitation here now. For that reason, that is above that one is presumed to cause, that is presumed to cause the over voltages, insulation failure, or it may be over excitation here. So this has only here now. Here we are using a tolerance envelope here now. If it is above that one, the percentage 106 we have shown here now, that will presume to cause the insulation failure. When the insulation failure will occur, when the over voltage is there. Okay, over voltages will come over there. So over voltage trip we can call that one, and over excitation it is going to fall. If it is less than that envelope, that is tolerant envelope, we are presuming that to load to drop out because there is a lack of energy is there. There is no sufficient energy to add the load over there. So that one we have described in this curve here. So the upper curve is actually defined down to 0.0001. Here they have mentioned here 0.0001 cycle, where it has a value of 375% of voltage here. Here 0.001 and about 375% of voltage they have shown here now. So this one we are going to call here now. Here 0.1 it has started. 0.1 it has started, but so but due to the some limitations we have to start from 0.1 only. We have started that one. So we typically employ the curve only from 0.1. Why we have not considered this 0.01 means typically we are going to employ from 0.1 cycle only and higher due to limitations of power quality monitoring instrument here. That is, there is a limitation for power quality monitoring instruments and differences in opinion over defining the magnitude values in the sub-cycle time frame here. For that reason, we are going to use the 0.1 cycle only, the starting, and to the up to higher values we are going to use. We are not going to consider because of some power quality monitoring instrument limitation. We are not starting from 0.001. So this is the CBEMA curve we have described here. Now, the which one it has given the tolerance envelope. If it is above the envelope, that is, it will cause us the insulation failure, over voltage strip, and over voltage excitation. If it is below the envelope, tolerance envelope, and that condition, what will happen? The load has to drop due to the lack of energy we have shown here. Similar way, the ITI has designed one curve, which one it is going to replace the CBEMA curve. The ITI curve will replace the CBEMA curve. It is going to replace that one here. We'll discuss that one. See here, the ITI curves we are going to discuss here now. The CBEMA organization has been replaced by ITI and modified curve has been developed that specially applies to common 120 volt computer equipment. This one it is going to consider common 120 volt computer equipment. It is going to tolerance. We are going to consider 120 volt here now. Okay, so the CBEMA curve, whatever the previous curve we have discussed, that one replaced by the ITI curve. Here there is no definition explanation is there. I have nearly taken 8 to 10 times. I have taken that CBEMA long form and ITI long form here now. Can anyone tell what you mean by CBEMA long form? Yes. CBEMA computer business equipment manufacturer association, that is called information technology industry, that is technological industry, that is called ITI. We have told that one. So this CBEMA curve has been replaced by ITI curve here now. that is applies the common 120 volt computer equipment, it is going to apply here now. So the concept is similar only. The concept of ITI and CBEA EMA curve is similar only, but what we are going to consider here now, this one, the modified CBEMA curve or modified curve they have developed by the ITI. What they have modified, we are going to discuss in this now. The concept is similar to CBEMA curve here now. Concept is similar, although developed for 120 volt computer equipment only. It is also developed for 120 volt computer equipment only. The curve has been applied to general power quality evaluations like predecessor curve here now. Predecessor curve means that is called CBEMA curve. Like this, it has applied to the general power quality evaluations here. So both the curves are used as a reference in this book to define the withstand capability of various loads and devices for protections from the power quality variations. Our aim is to protect the power quality here. Whatever the variations are there, voltage sag, swell, transients, harmonics, intra-harmonics, over voltage, under voltage, these all the variations we have to reduce that. Aim of that is reduce here now. So for that reason, both the curves we can take as a reference here now. We can take any one curve as a reference, and according to that, we can find that we can reduce the power quality variations over there. For display of large quantities of power quality monitoring data. So display the large quantities of power quality monitoring data, we frequently add a third axis to the plot to denote the number of events within the certain predefined cell of magnitude and duration here. Now the third axis they are going to add, I don't know, here they have not added actually here, 1 milliseconds, microseconds, like that. This is the ITI y-axis, the duration they are going to give here now. So here the applicable 120 volt, 120 bar 208, 120 bar 240 volt, the nominal voltage they are going to use here, this one. So for the 240 volt, it is going to 120 volts. They have taken reference here now. See here, this is the voltage tolerance envelope they have taken 120 to 80, 120, 80 to 120 they have taken here now. Here 120 we can consider that is as a envelope here now. Tolerance envelope we have considered here now. See here, previously the curve was started from 0.1, but here they have started from 0.001 also. See here, 1 microsecond they have considered here now, not 0.0001 cycle also. 1 microsecond, microsecond means 10 to the power of -6, 0.000001 seconds they have considered here. So this is the modification they have done here now. Previously what we have considered from 0.1, but they have considered here from 1 microseconds they have considered here now. We are going to get the clear picture of that one. This one, it is very high for the 1 microseconds. Then for the 0.1, suddenly it is going to drops here. Next for 0.1, it will comes under 106% here now, 140%, 120, like that. It is the voltage is coming to the above, it is going to maintain that above the tolerance here now. That below the tolerance, again it is lack of energy, it has to, we have to drop out the loads here now. Here over voltage and all the things, the concept is same only the curve duration it has changed over there here. So for display of large variations here now, that one over now, if restricted to just two-dimensional views shown in the figure below, the plot tends to turn into a solid mass points over time, which is not useful here now. The solid mass point over time we have considered is that is not useful, but the required is 0.006, 0.001 previously we have mentioned over there because of the limitations. So this curve, it has covered all from 1 microsecond to the upper, for the higher values it has described that. Now this is the ITI curve. There is no much difference, the concept is same only curve is different here now. This curve is different, other things it is constant only. Go for higher voltages, higher durations, it is constant only. Only at the starting only, whenever the switching will be occurs on that conditions, on the load switching on off, and that is capacitor switchings and all the things, here only the fluctuations will be occur or variations will be occur, that one within fraction of second. So that one for 0.001 or 1 microseconds we have to consider that. We have to consider that. So it completes the first unit, I think. It completes the first unit. It has been completed. Just completed. So I'll give some assignment questions. Take the assignments. So your ICA marks has assignment based on the assignment questions only. Write down. Define the following terms. Define the following terms. Define the following terms and write the causes. Define the following terms and write the causes. CAUSES. लिख रही क्या? All of you are writing?
Yes,
First
sir.
one, you write transients. Write the definition of transients. Transients इसको अभी सेकेंड यूनिट में आ जाएगा. कैंसिल करो transients नको. Directly you write over voltage, under voltage. First one is over voltage. Question is define the following and write the causes. उसमें first one Roman words लिखो. First one that is over voltage. Second one is under voltage. Under voltage. Third one is interruption. Interruption. Fourth one is voltage sag. Fourth one is voltage sag. Fifth one is voltage swell. Voltage swell. Voltage swell. Sixth one is voltage imbalance. Voltage imbalance. Noise. Seventh one is noise. Flicker. Last one is flicker. कितना हुआ? 8 क्वेश्चंस हो गए. डेफिनेशन कोई लिख रहे क्या?
Yes, sir.
8 हो गए ना?
Yes, sir. Yes, sir.
ठीक है. उसमें और एक ऐड करो. 9th वन पावर क्वालिटी बोल के मेंशन करो. डिफाइन पावर क्वालिटी. फर्स्ट क्वेश्चन ही वही ले लो. डिफाइन पावर क्वालिटी बोल के. डिफाइन पावर क्वालिटी. फर्स्ट क्वेश्चन ले लो. डिफाइन पावर क्वालिटी. Define power quality. Power quality and explain power quality issues and importance. Explain power quality issues and importance of power quality. Importance of power quality. Impacts का जरूरत है क्या? Third question. Explain the impacts of power quality. Third question. Explain the impacts of power quality. Impacts of power quality. Fourth question. Explain power quality problem. Evaluation procedure. Explain power quality problem. Evaluation procedure. Explain power quality evaluation procedure. कितना हो गया क्वेश्चंस? 2 से शुभम
4 हो गए.
टोटल 4 क्वेश्चंस हो गए. ठीक है. Fifth one, explain transients. Explain. Sorry, एक minute. Don't try to explain. Define transients and explain its types. Define transients and explain its types. Fifth हो गए. Sixth one, explain the waveform distortions. Explain waveform distortions. Waveform distortions. Sixth one, explain international standards of power quality. Explain international standards of power quality. Power quality. Last one, with need diagram, explain CBEMA and ITI curves. CBEMA and ITI curves. How many questions are there total?
8.
8 questions. Okay, these 8 questions you have to. So total 6 chapters are there, 6 assignments I'm going to give. So this is the first chapter. I was not getting the time, for that reason directly I have given. I'll prepare soon. I will prepare the assignment booklet and I will provide to you peoples. Okay. So here the first chapter is over. Whatever is there in the PPT only I have given. When I have the notes also, I will display and I will show you notes also. Same thing, but a little bit explanation is more, I think. MCQ is also prepared. So all power quality MCQs are already with me. I will upload in the drives. So these are the power quality MCQs. Is it visible?
Yes, sir.
So here with answers I have written, but for the answers explanation is not written. So you can do that one. The power quality generally used to express quality of service, computer equipment, quality of voltage, lighting equipment here. What it is, the power quality, what it is going to express actually? Especially we are going to concentrate on interruptions, voltages only, no, over voltage, under voltage and all the things. Yes or no?
Yes.
Voltage sag, voltage dip we are going to call, under voltage, over voltage. So that is quality of the voltage only we are going to concentrate. It is expressing here. What is the system ability to transmit and deliver electrical energy here? What it is? The ability to system, the system ability to transmit and it should have to deliver here. That is equipment quality. That is not computer quality. Computer ka kuch, it is not necessary here now. Power system quality. Power system means all here now. The particular ability to transmit and deliver electrical energy is nothing but over quality, over voltage quality here. If we are ability to transmit and deliver over voltage quality, then that is called the over voltage quality we are going to call here. So what was the problem occur? Like that, several questions are there here now. Several questions are there. You peoples practice it. So out of this one here, 8 questions we have taken, assignment questions. In that 8, first 10 questions should be MCQ. Okay, first assignment. Any 10 MCQs you have to write the answer that one. Any 10 answers you have to tell that one. So anyone, can you tell me this one? I will show here. The duration of voltage sag is less than what that one? Voltage sag. The duration of voltage sag is less than 20 minutes, 1 minute, 20 seconds, 60 minutes. Can you give the answer? Simple. We have shown in the table also. We have shown that one. Voltage sag and all of that. The duration of voltage sag is less than 20 minutes or 1 minute or 20 seconds or 60 minutes. Which one is the correct answer?
1 minute.
1 minute. Payal Sarkar has told 1 minute. Next, other persons. Shubham, Shraddha. Guess it. I am not asking, I am not expecting exact answer now. It will, you have the time, take tomorrow, day after tomorrow, 2 days time you take down, and on Wednesday be ready to for the chapter test. Chapter test होने के बाद मैं ये अपलोड करता हूँ, अभी तक तब तक नहीं करने वाला questions. Yes, Shraddha, rule number 1, are you there?
Yes, sir.
What is the answer, madam? Then I'm not asking the answer. I have given 4 options. In that one, you choose anyone. This is not a new system for you. It is very easy. You can choose anyone. 4 members are there. 4 options. You choose that one. Anyone will be correct. One will be correct. Payal Salgar has chosen B option. That is 1 minute. You choose one. Any one option. Shraddha. Rule number 1.
Yes, sir.
Which one is the correct answer? Alright. Are you silent? You choose any one. I'm not giving punishment if the wrong answer.
1 minute, sir.
Which one?
1 minute. B.
1 minute. Shubham. Dosi Shubham.
Sir, 20 seconds.
20 seconds. Next, Mule, Saurabh Mule. See here, the voltage sag is nothing but when the voltage will drop from 0.9 to 0.1. In between it, if it is dropped here, 0.9 to 0.1 per unit here. Okay, this is per unit here. So actual range of voltage sag is, that is called 0 to, that is 1 minute is that here. That is 1 minute. The duration is 0 to 1 minute. So on that condition, we are going to consider 1 minute only. Yes or no? So again in that one, instantaneous, moderatory and temporary, 3 categories we have made based on that one. That is 0.3 cycles to the 30 cycles. From the 30 cycles to the 3 seconds we have considered, and from 3 seconds to the 1 minute, that is called temporary we have considered here. So the duration of this one is 1 minute is correct answer actually. 1 minute is correct answer. We'll check that one. I don't know. As per my explanation, I told that one. That is answer B, which is that is. It is correct answer only B. Okay. So like this, you people, you practice it. Some MCQ questions you practice it. These many MCQ questions I have already with me. I will upload that one. So maybe on Wednesday, be ready for the chapter test. Be ready for the chapter test. All power quality related MCQs are present with answers. It is there. So I will upload in the drive and I will provide the link in the teaching diary. Okay, you can take this one, you can take the benefit and you can start preparation here. So even first unit PPT, I will share, and the notes also here, where it went. Power quality unit 1 notes. This is the notes with syllabus. We have already made this one. Some corrections and all the things. Some spelling mistakes we have to check. That is the pending work. So I will upload this one in the PDF file. I will upload. You can take the notes also. Printed notes are available. Okay. So be ready for the chapter test. Anything you want to ask? Just a minute. One person is Siddhi Sindhe. I don't know who is. I will add them first. Then we'll ask. Who is this Siddhi Sindhe? They are not ready to join. Audio join nahi hua abhi. Siddhi Sindhe. Okay, no problem. So absent roll numbers, I will call roll number 2, roll number 4, roll number 6, roll number 10, roll number 17, roll number 30, 31, 32, 35, 37, 41, 42, 44, 45, 48, 49, 50, 52, 54, 55, 56, 58, 59, 61, 62, 64, 66. Anybody is there? So we'll stop here only and we'll continue on Thursday. Wednesday you have the chapter test. The same time class timing I'll conduct, put the link, Google form, and you can submit it. Okay, we'll stop here only.